about this homework assignment that we're working on. It's on the screen. Regarding this homework assignment, you'll notice that on reflection, I changed a couple of things, but I didn't make all the necessary changes, of course, apparently. I've changed the first couple of sentences up there about the data. I changed the nature of these restrictions. Okay, before I had just written them as sums, and I wrote them out more explicitly because the way I had constructed the sum wasn't quite correct, because I had misinterpreted the article that I had read and on which I based the homework assignment. So I fixed these restrictions. And then this question about A came up again. What restrictions would be necessary for the cost function to be homothetic? We'll try this, I think, the same hint that we had on the board a little while ago, or last week, when I talked about this. Suppose you had two inputs, capital and labor. Does it matter that in this homework we have four? No. Whatever works, whatever we say in two dimensions is also true for four dimensions. That's the beauty of math. If you can show something in the simple case, show it to be true, more often than not, you can show it to be true in the more general case. So we'll look at a very, very specific case. And we're going to we have a production function. The output is produced from capital and labor. And in the capital labor plane, we get some isoquants. In order to derive or prove all kinds of propositions in micro theory, one of the things, among the many things that we say that the marginal product of, say, capital is positive, but that the marginal product of the second derivative with respect to capital is less than 0. So its marginal product is increasing, but at a decreasing rate. So we say things like that. And then we also say that for this well-behaved production function, the cross derivatives have to have a particular sign in order for this to be well-behaved. And so all these well-behaved things we need in order to prove certain propositions. And there are some very abstract propositions that rely on the production function being homothetic. In order for the production function to be homothetic, it requires that if you draw a ray out of the origin, and it could be any ray. Mine looks like it's 45 degrees, but it's not. It could be any ray. The marginal rate of technical substitution evaluated at, let's give these 2 points names, point 1 and point 2. Evaluated at 1 has to be equal to the marginal rate of technical substitution evaluated at 2. That means that the ratio of the first derivatives of f with respect to k and then with respect to L, that ratio is unchanging with respect to output. Does that mean that it's unchanging with respect to input prices? Right. This means that it doesn't make any difference what isoquant you're on to know that the marginal rate of technical substitution is the same all the way along that ray for a given set of input prices. Okay? So when you derive the first order conditions for that factor price frontier, so when you derive the first order conditions, their ratio, which are in fact the nature for each one of those first order conditions, can be derived from any one of the first order conditions. You can derive the demand for the inputs, and so they are in the nature of the first order conditions of the production, solving the production problem. Those ratios can change with respect to prices, but with respect to a change in output, they shouldn't alter. Okay, so that's another hint. And another part of the question had to do with the degree of homogeneity. And again, simple definitions often work best. And by simple definitions, I mean recalling things that you learned in principles of microeconomics. Certain things that you learned and memorized. So, for example, one of the things that you learned and memorized in principles of microeconomics, talking freshman econ, one of the things that you learned or memorized was that if a firm is characterized by increasing returns to scale, then its average cost curve is declining throughout, meaning the double output cost less average cost less than doubles. Or, I'm sorry, total cost less than doubles. Well, you've got a cost function, right? I gave it to you. And it's a function of prices and outputs. So you have to decide on the restrictions that you need to impose on that cost function so that, for example, cost could be completely independent of scale. Or cost is homogeneous of degree 1 in output, and so on. So in the context of the isoquant, you could ask yourself, well, when I'm on isoquant y0, I know that I bought this much capital and that much labor. And so suppose prices are the same. I double all my inputs, the quantities of my inputs. Not the prices of the inputs, not my expenditure on the inputs, the quantity of inputs. I double them both, so output either doubles or less than doubles or more than doubles. That's what returns to scale is all about. Well, suppose you double all your inputs and your output more than doubles. What's going to happen to unit cost? It's going to go down. Okay, so with the information that you have, that's a pretty simple question to answer. Yes?
I apologize. I don't have the green book in front of me, but when I was reading the Translog section, I believe we made a substitution where you look at total cost and total output, and you divided it by total output, so I was looking at it on a per unit basis, and the y terms drop out. Is that?
I didn't look that closely at what he had in the book.
Basically, he divides all the terms by capital Y. And you have a lot of
I don't remember that.
one that drops out, and you don't have to deal with all those terms at the bottom. I didn't know whether that was.
Well, you're talking about equation 1031 and what follows on page 276. But you got to read the line that follows it. What's the line that follows equation 1031 say?
Okay, if there are constant terms.
Read it again, a little louder. Emphasis on the first word.
If.
Uh-huh.
That's constant terms of scale.
Right, so that's a testable proposition, right?
Right.
So if you divide through by Q, you're presuming that constant returns to scale exist, and it's no longer you've turned the testable proposition into something that you claim to be a known fact. Yes.
For C, can we assume that the restrictions about can we assume that the constant return scale exists? No.
C says what restriction would be necessary.
For after C, can we assume the constant?
Oh, no. No. No, I just got through telling Salad that this is a testable proposition. Right? So it's like arguing from the conclusion that you want back to the starting premise.
So for D, we can't assume that there are.
No. That would make life easy, but it's not a very interesting exercise because that already exists in your textbook.
No.